Thank you for the introduction. First of all, well, welcome to the session, everyone, and good afternoon. So today, what I'm going to do is to talk about a new category of infrastructure, which we call data in motion, and how this is interacting with the current trend where everybody's moving towards the cloud. See, when people talk about this new category of data in motion platform, most people will think about the technology called Apache Kafka. So if you are new to Apache Kafka, it is actually one of the most popular active projects among the 300 or so Apache projects out there. And it's used broadly by hundreds of thousands of organizations across the globe and across industry, and including some of the largest, most of the largest Fortune 500 companies. And if you look at the statistics, how much volume of data is flowing through this system, the number is pretty impressive. So how did this technology get started? Well, some of you may have heard that Apache Kafka was originally created at LinkedIn. I was fortunate to be at part of LinkedIn at the time when Kafka was developed. Around that time, LinkedIn was only like 600-ish people. I spent about 4 years there. And during that 4 years, LinkedIn had its fastest growth and it grew to 6,000 people when I left. So there's a 10x growth in terms of the number of people as well as the business. And if you look inside, what's really powering that fast growth of LinkedIn? It's all about its ability to leverage its data. So today, I think this seems to be a common cliche. Every company wants to be digital first and everyone wants to be data driven. But what's unique about LinkedIn leveraging of this data is there are a couple of pretty deep realizations LinkedIn had that allowed it to have this deeper leverage of its data. And then next, I'm going to share what is two insights with you. The first thing LinkedIn realized is this, which is leveraging data in motion allows LinkedIn to have a much deeper leverage of data than the traditional way of leveraging at rest. Now, what do I mean by that? Well, it's useful to illustrate this through an example. If you look inside LinkedIn, it's actually a website composed of hundreds of microservices. So these are some of the example services out there. For example, LinkedIn has this email service, which composes some email digest about what's interesting that's happening in your network connections. LinkedIn also has this recommendation engine, which recommends some other LinkedIn members that's not in your connection yet. And a lot of those recommendations will be using information, right, such as your education history, your work history. LinkedIn also has a search index, which gives you this ranked search results based on, again, I think some of the information you provide, such as your job history, your educational history, that matches the search of the person or the company best for you. So as you can see, all those microservices, they need data, right, that's generated from LinkedIn, like, I changed the job. But the way historically those services have been leveraging data are what we call those data at rest, which means when something interesting happened at LinkedIn, let's say someone changed the job, right? So that information is, when it happened, it's primarily just being recorded, like in the database. But the leveraging of data in those microservices, like the email service, recommendation engine, search index, often happens much later, and typically is done through like a weekly or maybe daily jobs. So what LinkedIn realized is this is actually not the best way to leverage data and then provide this good user experience. So what LinkedIn wanted to have is what we call data in motion way. So when something interesting happens, like a job change, right? In addition to record this information, we want that information to be propagated and leveraged in all those services in real time, as soon as possible. So with this change, I think over time, what LinkedIn have been doing is to change all those services. Instead of doing this data at rest implementation, they are all changed to be event-driven. So all those services will be constantly listening to what's interesting happening at LinkedIn, and then it will be incorporating those interesting events into its service. The end result of this is all those services LinkedIn have built over time are much more engaging with this change by leveraging data in motion. So that's the first insight I want to share with you guys, which is leveraging data in motion is actually a much more effective way of leveraging the data than the traditional way of leveraging the data at rest. The second realization I want to share with you is the need to leverage all digitized information. Now, what are all the digitized information LinkedIn has? Traditionally, LinkedIn has mostly been focusing on what we call this transactional type of data. These are the data that the user has been explicitly giving to LinkedIn. For example, this will be your all the information you have in your job profile, such as your educational history, your job history, and your connections to other LinkedIn members. But what LinkedIn realized is there is a far greater amount of non-transactional type digitized information that's as useful to LinkedIn as those transactional events in terms of understanding the user behavior. For example, if you clicked on the link at LinkedIn, right? If you type some keywords to try to search for a person or for a company, these actually are information that are not transactional per se, but they carry very strong intention on what the user wants to do. So by leveraging this information, LinkedIn have a lot more opportunity to improve its service to be far more engaging. So if you look at the volume of those data, this non-transactional type of data can easily be 100 or 1,000 times bigger than those transactional data. So if you want to be a digital-driven company, right, you have to leverage all those data. You can't say you'll be ignoring 99.9% of data in your company. So that's the second realization LinkedIn had, which is the need to leveraging all the data, not just the traditional transactional type of subset data. With these two realizations LinkedIn had, when LinkedIn went back to look at all the existing system to see, what are the infrastructure it can use to support these two realizations, it just realized, surprisingly, around that time, there actually wasn't like a good infrastructure to do both what LinkedIn wanted. Around that time, there were two typical infrastructure data systems people have been using. The first one is various database technologies. And if you look at those databases are pretty good at storing data at rest, but they are not really designed for data in motion. They are not designed really to take actions in real time as those new interesting information are happening. The second system a lot of places have been using are all those sorts of messaging systems. And if you look at all those messaging systems, they are indeed designed for data in motion. You can actually act on those events in the message queue in real time as they are happening. But the problem is a lot of traditional messaging systems were really designed to only handle this traditional transactional type of data. So when you try to flow 100 or 1,000 times more amount of data on those systems, a lot of them will just stop working. So because of these limitations, LinkedIn realized to satisfy this realization LinkedIn had, right, we really need a new system to support those. So that's why Kafka was born. When we first designed Kafka, our goal is really to have a new system that can support this new category data in motion processing at scale. So in the first version, we revolutionized how we store the data so that we can do this data in motion at scale. The first thing we did is to introduce this concept of log. You will see these are all those little cylinders in the middle. This is the primary way we capture the data in Kafka, and this is actually the way that makes it much easier for recording new information and also delivering those data to applications in real time. The second thing we did is to make this system more scalable. So even in the first version of Kafka, this is designed as a distributed system. In a typical setup, you will have multiple of those servers we call brokers, and those commit logs that we mentioned earlier, you will typically have lots of those, thousands of hundreds of thousands of those in the system, and they will be spread evenly among those brokers. Now, with all those aggregated computing resources, we can scale the system as we need. We can handle that allowed us to handle this 100x or 1,000x more amount of digitized information. And over time, if your business grows and you need more capacity, is also easy to accommodate by just adding more of those computing resources. So this is the first thing we did, is to rethink about how we store the data to make this the data really a first-class citizen for data in motion at scale. Over time, we also added a couple of other components to make the system more complete. The first component we have added is a connection system. What we realized is, for a lot of enterprises, right, like LinkedIn, if you have a little bit of history, over time, you will have this issue where your data is in all those different siloed places. You know, you have data in various databases, maybe in some files, right, maybe in some traditional messaging systems. To really take advantage of this new data in motion system, the first thing you have to do is to get all your existing data integrated into this new platform. So it's kind of tedious for everyone to write a little bit of this adapter, right, for each of those databases. So what we added is a connection framework that allowed people to add those common data sources and data sinks connected into Kafka. So over time, we have hundreds of those connectors built on this connector framework. So now, if you want to use this technology, right, to solve your problem, chances are you don't have to write any customized code. You can just download one of those connectors, and then the data will be flowing into and out of Kafka easily. Another component we have been adding to complete this platform is the processing layer. So once all the data in your company are integrated and made available as real-time feeds in Kafka, what we notice is a lot of applications, especially those event-driven applications, have some common patterns of leveraging the data, because often what they want to do is to do a little bit of massage of the data, right, so that they can get deeper insight onto this data. So some of those would include a little bit transformation of data from one format to another. They may include a little bit the projection, filtering, a little bit data enrichment, maybe joining multiple streams, right, and then also maybe doing some aggregation over some time window. So doing all this in some low-level programming code can be error-prone and can be a bit tedious. So to make this kind of event-driven processing easier, what we have been doing is added some corresponding continuous processing framework to make the job of those event-driven applications easier. The first thing we have been adding is a Java library that called Kafka Streams. So this library provides a little bit like a higher level methods for people to define those common processing patterns like filtering, projection, aggregation, enrichment, a little bit easier than just low-level code. Another library that we and other communities have been adding is a more declarative level, a more declarative support for this kind of continuous processing. For example, at Confluent, we have a system called KSQLDB, which provides a SQL-like interface for people to define this continuous processing. With this, now even if you are not a Java developer, as long as you have some familiarity with SQL, you can potentially use this framework to do this event-driven processing for building applications. With all this, we now have a complete data in motion platform. In the middle, this is we have the real-time storage engine powered by Kafka, which allows us to store the data in real time at scale. With all the connection framework, we allowed all the rest of the ecosystem in this digitized world to be integrated with Kafka easily. And then with the processing frameworks such as Kafka Stream and KSQLDB, we allow people to build those event-driven applications on this platform much easier. So with this platform, that's what we are seeing. There's a lot of the new category business applications being built on this new platform. And fast forward to now, what we have seen is Kafka is now becoming this de facto standard for this new category of platform we call data in motion. But as with any data platform, right, I think a lot of success of a platform is continued innovation. So what's next? What's the next innovation in Kafka in this space? For us, we believe the next wave of innovation will be coming from the cloud. So when Kafka was originally started, right, that's about 10 years, 10 plus years ago, our users have no choice but to self-manage their own Kafka clusters. If you have managed like any distributed system like Kafka before, you will know managing like a distributed system like Kafka is not easy, because you have to worry about all the configuration, the tuning, the upgrading, the balancing of the data, right? And then the monitoring, the logging, and the alerting, and so on and so forth. So fast forward to now, Kafka is now available as cloud managed service by many like vendors in this space. With this cloud managed Kafka, it completely take away the operational part of Kafka, because our users can now just use like a managed service, and then which will take care of all the operational part for Kafka. And our users can now just focus their attention on their core business value, which is probably where they can spend their time better. Cloud management service not only take away the operational part, but it also allow people to get started earlier, and in the end can translate into a much lower total cost of ownership. But offering Kafka in the cloud is really just the first step. We believe there's a lot of opportunity in this space for us to rethink about what's the cloud native architecture for this platform, so that it can run in the cloud better and provide a much better service. Cloud behaves a little bit different from on-prem. In on-prem, you can sort of you buy your hardware ahead of time, and then after you can sort of use it for free. But in the cloud, the model is you typically pay what you've been using. So by judiciously rethink about how those cloud resources can be used, we can have a lot of opportunity to provide a much better service, and a lot of that translate into a lower total cost of ownership. Next, I'll just share one example of such kind of innovation to make cloud native architecture in the cloud that made a key difference in Confluent Cloud. If you're familiar with Kafka, you will know this is how Kafka stores the data now. So each of those brokers will have some local storage, and all the data in Kafka will be distributed among those local storage in those brokers. Now, what's the issue with this architecture in the cloud? Well, the first problem is cost, because Kafka is really designed for real time, right? So to provide those real time experience, you sort of have to use those high-end fast type of storage for those local storage. And if the data is significant, right, and then you end up paying a lot just for the storage cost. The second problem with this architecture is in terms of elasticity. As you can see, because the local storage is coupled with the broker, so that means this architecture doesn't allow you to scale the storage need from the computation need of the broker independently. For example, if you are running out of local storage, now the only way you can do is to add more brokers, but that just means you are wasting some of the CPU resources, right? That's not needed when adding those new brokers. So what we did in Confluent Cloud is to rethink about how this architecture should work in the cloud. So in particular, what we did is to introduce this remote type of storage. So within each broker, we now, instead of having this one type of storage, we'll have two types of storage. We'll continue to put some of the hot set of data, which is the most recent data, in those fast type local storage, because that's helpful for delivering real-time experience for Kafka. But for the bulk of historical data, we can choose to archive them into external object store, which offers much better cost and throughput trade-off than the fast type of local storage. And then within each broker, we just need to keep some of the references in each of those brokers. With this architecture, it actually significantly changed the trade-off in the cloud setup. The first benefit we got is in terms of cost, because the object store type storage is much cheaper than the fast type of local storage, we can significantly reduce the local storage cost. The second thing is we have, because of this, the leveraging of external remote storage, we have completely decoupled the storage need from the computation need, because now you no longer need to add more brokers just for storage need, because the external object store has infinite capacity. Now, if you do need to add more brokers for computation need, you can do this much more efficiently than before, because there's only a small amount of local storage that need to be kept. So this is just one example how, by rethinking about the overall architecture in the cloud, we can provide a system that's much more efficient in the cloud. Now, with this data in motion platform in the cloud, how are people using it? Next, I want to share with you like one example how this platform in the cloud has been helping one particular user to revolutionize its core business. So this is about a cloud-native retail bank. This bank is unique in that, unlike the conventional brick and mortar banks, this bank has no physical facilities. It has no physical branches. Everything is in the cloud. As a matter of fact, the whole company was built in the cloud, in the cloud just in under 300 days. The overall architecture is composed of 60 plus of microservices. All those microservices were designed to be event-driven. They will be constantly listening to new information that's coming into the user's saving and checking account and credit card activities, among others. And all those event-driven applications will be constantly listening to what's happening for the users, and then act on behalf of the user to provide those better real-time experience for the user, as well as to derive those deeper insights for the user, so that they can manage their financials better. And the core of the system is leveraging two cloud infrastructures. One is Kafka using Confluent Cloud. The other is MongoDB through Atlas. By using these two cloud managed services, this company was able to focus on their core business and can build this new platform from ground up in less than a year's time. So this shows the value of leveraging this cloud-based managed services. Because of the leveraging of this event-driven architecture and leveraging this data in motion platform, the service this bank provides is much more engaging for the user. As a result, even though this bank is relatively new, but for the services they are offering, they are considered the best in those categories. So this is actually one particular use case I want to share with you. Just to conclude, what we have seen is an area where there are lots of interesting things happening. And the one particularly interesting I talk about is this new category of platform, which we call data in motion. This is a platform that behaves a little bit different from data at rest. Instead of just recording the information when some interesting things are happening, this platform provides an opportunity for applications to act in real time on what's happening in your business and take advantage of that. The end result is a lot of new applications can be built that are far more engaging for the user and then providing far more value for the end users. Another significant trend we have been seeing is the rise of the cloud. So cloud managed services provides an opportunity for the end users to adopt new technologies such as Kafka much easier, because they don't have to physically operate this platform. They can just set it up in the cloud and let someone else manage those, and then use that to build those new applications. And by rethinking about how those new platforms such as Kafka running in the cloud, we can provide a service that's much more cost effective and much more resilient for the end user. So over time, we believe there will be a lot more of those event-driven applications built using this new data in motion technology based on Kafka, and then leveraging those services in the cloud. With this, thank you everyone for listening, and I think we have a little bit of time to take some of the questions if people have. Okay, so I'm just reading some of the questions from the live channel. The first question is, does Kafka support Apache Arrow format? Well, that's a good question. In Kafka, if you look at how Kafka stores data, right, the way we store the data in Kafka is not tied to any particular message format. It's really just like opaque binary data. Because of this, you can actually support any popular data format you want. So in there are a lot of places, you know, they can use JSON format, they can use Arrow, they can use some of the libraries provided from Google. So there's a lot of flexibility there.